The electrical practices and procedures presented in this book are based on the National Electrical Code, hereafter referred to as the NEC or the Code. Sponsored by the National Fire Protection Association, the NEC establishes national minimum safety standards for the installation of electrical wiring and equipment. The code has one purpose: to safeguard people and property from hazards arising from the use of electricity. It is designed for mandatory application by any authority having legal jurisdiction over electrical installations. By conforming to the NEC, a book such as this can provide accurate instructions to a nationwide audience of readers, even though they are governed by local electrical codes that can vary from community to community. Most of these local electrical codes, whether city, county, or uniform state codes, are based on the NEC, but they may vary in significance or may not be as up to date. The NEC revises the code every 3 years. Since all electrical work in the home must be done according to code, you must check out your local electrical code before you even begin planning your project. To do this, contact the building inspection department for your community, usually located in City Hall, and ask for a list of electrical code requirements. Also ask if the code follows the NEC. If there are significant deviations, what are they? Some local codes may regard the NEC as an acceptable alternative. Whatever the situation, all your electrical work must be done according to the code used by the authority that has jurisdiction over your residence. Even though you have a copy of your local electrical code, you should still familiarize yourself with the NEC. The best way to do this is to obtain a current guide to the NEC because the code itself is quite complex. You are charged for the electricity you use in kilowatt hours. Kilo means thousand, so a kilowatt is 1,000 watts. These kilowatts are measured by the electric meter attached to the house, which runs continuously and registers your use on the 4 or 5 dials on its face. Some meters have a counter similar to the mileage indicator on a speedometer, but most have dials that resemble clocks, with numbers running from 0 to 9. Look closely at these dials and you'll see their numbers alternate between running clockwise and counterclockwise. To read your meter, start with the left-hand dial and work to the right, jotting down the numbers as you go. If the hand lies between 2 numbers, always use the lower number, even if the hand is almost on the higher number. However, if the hand is directly on a number, check the dial immediately to the right. If the hand on that dial has reached or just passed 0, use the number indicated on the previous dial. However, if the hand of the dial on the right has not reached 0, use the next lowest number on the previous dial. Some homeowners like to take their own meter readings every once in a while in order to check the accuracy of the power company's readings. To do this, write down the meter reading at the same time the company reads the meter. Do this again the following month and subtract the first reading from the second reading. Then compare your consumption with that stated on your electric bill for that month. If there is a significant discrepancy, contact the power company. Branch circuits within the home are formed by the wiring that connects electrical outlets, receptacles, and permanently connected appliances to the service entrance panel. Each individual circuit has its own hot wire and neutral wire as well as an overcurrent protection device capable of turning off power to the individual branch circuit. In the panel, 2 hot wires from the main circuit breaker energize 2 bus bars constructed of heavy metal, usually copper or aluminum. Each branch circuit is connected to one or both of these hot bus bars via individual overcurrent protection devices, either circuit breakers or fuses. A 120-volt circuit has 1 hot wire coming from a single-pole circuit breaker, that is, a circuit breaker connected to 1 hot bus bar, and a neutral wire or conductor that is connected to the neutral bus. A 240-volt circuit has 2 hot wires connected to a double-pole or 2-pole circuit breaker, that is, a circuit breaker that is connected to both hot bus bars. However, this 240-volt branch circuit may or may not have a neutral wire connected to the neutral bus. That's because 240-volt circuits for water heaters and large air conditioners do not require neutral wires. It is important to remember that all neutral conductors terminate at the neutral bus. Most homes are equipped with a variety of branch circuits. The NEC recognizes 3 types: